All right, so let's generalize about the discriminant. So remember, the discriminant is this value underneath b squared minus 4ac, right? So we know that if the discriminant is positive, if it's greater than 0, we're going to get 2 real roots, right? We've seen that play out a couple times. So we know this is the case. And then we also saw down here, if b squared minus 4ac is a perfect square, like, 0 squared, 1 squared, 2 squared, 3 squared, 5 squared, etc., we're going to get 2, 1 or 2 rational roots, right? Which means roots that we can express as a fraction, okay? If b squared minus 4ac is not a perfect square, so to counter that, if it's not a perfect square, then that means we're going to get irrational roots, right? Not perfect square. Then that means we're going to get irrational roots, 2 irrational roots. And actually, it could be 1 or 2. So let's just say 1 or 2. All right. Okay. So we look at if it's positive. If it's positive, we look at if they're perfect squares or not perfect squares, and that tells us if they're rational or irrational. Now, if b squared minus 4ac, if the discriminant is less than 0, that means we're going to get no real roots, right? Which means we get 2 complex roots. Okay, so we get 2 complex roots, and and we can look at the graphs here. That's going to be a situation where it doesn't cross the x-axis, right? If we get 2 real roots, it's going to cross the x-axis, right? And whether it's rational or irrational, those are real numbers. So if b squared minus 4ac is positive, it's going to cross the x-axis, right? Whether it's facing up or facing down, it's going to cross twice. If b squared minus 4ac is less than 0, if it's negative, it's not going to cross, right? All right, and then the way we get 1 real root, and we haven't seen this yet in our examples, but we may or may not see it soon. But if b squared minus 4ac is 0, we get 1 real root, and that means it just touches the x-axis once. So it's either on top, it's either right on it, where the vertex is on the x-axis facing up, sitting on it, or it's facing down, perching from it, right, hanging from it, from its vertex. All right, so let's see one more of these examples. This time the directions are a little bit different, so you'll see some of these on the assignment. So here we're going to find the value of the discriminant, right? We do that anyway, so we're really not doing any more work except for step B, where we're describing the number and type of roots, okay? But make sure you list the discriminant for part A. So I'm going to do the same thing. I'm going to set one side equal to 0, done. I'm going to identify A, B, and C. A is 9, B is negative 24, C is 16. And then we're going to set up our template, right? And remember, you can go straight into plugging it in, whatever makes most sense to you. All right. And so I'm going to start with B, negative 24. That goes here and here. Then A is 9, so that goes here and here. And C is 16, so that goes there. All right, so now when we simplify, negative negative turns into a positive, so I get positive 24 plus or minus. And then let's do what's underneath the radical here, the discriminant. So here, 24 squared is 576, so we get 576. And then negative 4 times 9 is negative 36, and negative 36 times 16 is, 36 times 16 is also 576, so we get minus 576 here. Okay, and when we simplify that on the inside, 576 minus 576 is 0, and the square root of 0 is 0, right? So here the discriminant is equal to 0. So for part A, the discriminant is equal to 0. Okay. All right. For part B, describe the number and type of roots. So if we go back to our previous slide, we know that if the discriminant's equal to 0, we have one real root, okay? And it's also 0, which is a perfect square, so that means it's going to be a rational root. All right. Okay, so we have one real and rational root. Okay, so remember, real because discriminant's equal to 0, and rational because 0 is a perfect square, right? All right. So now let's finish working at this out. So we have 24 plus or minus 0. 2 times 9 is 18. Right? Plus or minus 0 goes away. So that's how we only have one solution, is because we're not adding and we're adding and subtracting 0, right? Adding 0 to 24 is the same as subtracting 0 from 24. We get 24 either way. So we get 24 over 18. We can reduce that. 6 goes into both, so it's 4 over 3. So that's our final answer, is 4/3, just one answer this time. Okay, so that's when we get one solution, is when the discriminant is 0. So what's underneath here, if that comes out to 0, you're going to get one solution, and it's going to be real and rational. Okay, so here's our exact solution. All right, so you'll have a few of these on the assignment where just do the normal thing, but once you find your discriminant, make sure that you list that for part A, and then use that to figure out what type of roots you're going to have, and then just put your answers as normal. Okay, so you're just going to use this table, or just your memory, your notes, however you remember these things. This table will kind of tell you how many roots you have and what kind of roots they are. Okay. All right. So if it's one real root, it's always going to be rational because 0 is a perfect square. If it's two real roots, it could be rational or irrational depending on whether it's a perfect square or not a perfect square. And then if they're complex roots, then you don't have to worry about rational or real because they're not real. Or you don't have to worry about rational or irrational because they're not real in the first place. So you can just put two complex roots. All right, if the discriminant's negative.